The James Webb Space Telescope stands as one of the most sophisticated scientific tools ever created, transforming our comprehension of the universe by breaking new ground in space exploration. Since its launch in December 2021, JWST has already uncovered several revolutionary findings, from capturing the birth of distant galaxies to observing exoplanets in unmatched detail. However, nothing could have prepared the scientific community for the recent signal it intercepted from the Andromeda Galaxy, one of our closest galactic neighbors. This enigmatic and puzzling event has sparked both excitement and unease among scientists and astronomers alike. The implications of this mysterious transmission are monumental, with the potential to reshape our entire view of the cosmos. The Andromeda Galaxy, located around 2.5 million light-years from Earth, has long been a focal point for astronomers. As the closest spiral galaxy to the Milky Way, Andromeda offers a rare chance to study a galactic system that may, in many ways, resemble our own. While scientists have extensively mapped its stars, nebulae, and planetary systems, Andromeda has never been a source of major anomalies, until now. The recent signal detected by the James Webb Space Telescope is unlike anything previously recorded from Andromeda or any other galaxy. Its unique characteristics, frequency, structure, and duration, suggest it could be artificial, possibly indicating the presence of an advanced extraterrestrial civilization. If true, this would mark the first time humanity has detected an artificial signal from beyond the Milky Way. The nature of the signal itself is perplexing. Unlike natural cosmic phenomena, such as radio waves from pulsars or fast radio bursts, this signal displays a highly organized pattern that doesn't seem random. Initial analyses show that the signal repeats at consistent intervals, suggesting the presence of some encoded information. The specific frequency at which the signal was detected falls within a range long believed to be optimal for interstellar communication, often referred to as the water hole in radio astronomy. This frequency range is considered naturally quiet, making it ideal for transmitting long-distance messages across the cosmos. For decades, scientists have speculated that if intelligent extraterrestrial civilizations exist, they would likely use this frequency band for their signals. The Andromeda signal picked up by the James Webb Space Telescope aligns with this theory so well that many researchers believe it can't be merely coincidental. However, as enticing as this possibility is, definitive proof remains elusive. The signal could theoretically stem from a previously unknown natural phenomenon, yet its regularity and complexity continue to pose challenges to natural explanations. This discovery has ignited a wave of debate and investigation within the scientific community. Various observatories worldwide are now focusing their instruments on Andromeda, hoping to confirm or dispute the findings. While the initial data from JWST is groundbreaking, scientists are cautious about jumping to conclusions. History has shown that the search for extraterrestrial intelligence, SETI, is riddled with false positives. In the past, signals initially thought to originate from alien civilizations were later traced back to mundane sources like satellites or even microwave ovens. Despite these cautionary tales, there's a palpable sense of excitement in the air. The mere existence of such a signal is a testament to the advanced capabilities of the James Webb Space Telescope, whose sensitivity to faint signals from distant galaxies far surpasses that of any previous telescope, including the iconic Hubble Space Telescope. The JWST's capability to collect data across a broad spectrum of wavelengths, including infrared, has paved the way for new exploration opportunities. This recent detection highlights just how much we still have to learn about the universe and the potential for unexpected discoveries. One of the most intriguing aspects of the signal is its potential implications for our understanding of life beyond Earth. For centuries, humanity has pondered whether we are alone in the cosmos. The discovery of exoplanets within habitable zones, where liquid water could exist, has fueled speculation about the presence of extraterrestrial life. However, until now, no concrete evidence has suggested that intelligent life exists elsewhere in the universe. If the signal from Andromeda turns out to be artificial, it would be a game changer. Not only would it confirm the existence of intelligent life beyond our solar system, but it would also imply that such civilizations possess the capability for intergalactic communication. The ramifications of this are significant. First, the ability to transmit a signal across a distance of 2.5 million light-years indicates a level of technological sophistication that far surpasses anything humanity has achieved. For comparison, the farthest signals we have sent into space, such as those from the Voyager probes, have only traveled a few dozen light-hours from Earth. If the Andromeda signal is indeed artificial, it prompts questions about the civilization that sent it. Are they more advanced than we are? Have they been observing us longer than we have been aware of their presence? Perhaps most intriguingly, what message, if any, are they attempting to convey? The signal could also reshape our understanding of the timeline of intelligent life in the universe. Additionally, Andromeda is on a collision course with the Milky Way, set to merge with our galaxy in about 4.5 billion years. If an intelligent civilization exists in Andromeda, they may be aware of this impending fate and could even be preparing for it. The concept of intergalactic civilizations interacting or merging during a galactic collision adds another layer of complexity to our understanding of the universe. This adds another layer of complexity to the already mind-bending idea of extraterrestrial life. Furthermore, the detection of this signal raises new questions regarding the Fermi paradox, which highlights the contradiction between the high likelihood of extraterrestrial life and the absence of evidence for it. If the Andromeda signal indeed originates from an advanced civilization, it might provide insight into why we haven't heard from other civilizations until now. Perhaps the vast distances between galaxies render interstellar communication rare or challenging, or maybe civilizations only begin to communicate once they reach a certain technological level. Another possibility is that the signal represents an attempt at first contact. If the Andromeda civilization is aware of our existence, they may be reaching out in hopes of establishing communication. However, the fact that the JWST only recently detected the signal suggests that their message, if it is indeed a message, was sent millions of years ago. This raises the question of whether the civilization that transmitted the signal still exists. Given the time it takes for a signal to travel between galaxies, the Andromeda civilization might have evolved, gone extinct, or changed in ways we can't even fathom. In addition to these philosophical inquiries, the discovery of the signal poses numerous practical challenges. Decoding the signal, if possible, would require immense computational power and ingenuity. If the signal contains information, it may be encoded in a manner entirely foreign to us, necessitating the development of new techniques and algorithms for data analysis. This endeavor could potentially lead to breakthroughs in artificial intelligence and cryptography. Additionally, any attempt to respond to the signal would require significant advancements in our own technology. Sending a message back to Andromeda and ensuring its reception could take millions of years, assuming we possess the capability to send signals over such vast distances. There are also ethical concerns surrounding the implications of responding to the signal. The prospect of contacting an extraterrestrial civilization carries inherent risks. Some scientists argue that disclosing our presence to an unknown civilization could be perilous. If the Andromeda civilization is more advanced than we are, they might perceive us as a threat or view us as a species to be subjugated. Conversely, others contend that any civilization capable of intergalactic communication would likely be peaceful, having transcended the challenges of war and conflict to focus on scientific and technological advancement. Regardless of the potential dangers, this discovery has rekindled public interest in the search for extraterrestrial life. News of the signal has spread rapidly, captivating the imaginations of people worldwide. Speculation about the nature and origins of the signal has ignited renewed enthusiasm for space exploration, with many advocating for increased funding for SETI and related initiatives. Some even suggest that this could be the catalyst for a new era of space exploration, one in which humanity takes its first steps toward becoming an intergalactic species. As scientists continue to analyze the signal, one thing is clear: the James Webb Space Telescope has once again demonstrated its value as a tool for exploring the unknown. Its ability to detect faint signals from distant galaxies has opened a new frontier in the quest for extraterrestrial intelligence. Whether the signal from Andromeda ultimately proves to be artificial or not, it has already broadened our understanding of the universe and the possibilities it may hold. This discovery serves as a reminder that, despite all we have learned, there remains so much we do not yet know about the cosmos. Each new observation brings the potential for surprises, and the Andromeda signal may be the most tantalizing surprise of all. One of the most immediate challenges stemming from the detection of this signal is the question of verification. As exciting as this discovery is, the scientific method requires rigorous scrutiny and repeatability. To truly confirm that the signal is artificial and not simply an unexplained natural phenomenon, further observations will be necessary. The James Webb Space Telescope, impressive as it is just one tool among many. Other telescopes around the globe and in space are now concentrating on the region of the sky where the signal was detected, striving to capture the same signature. The goal is to have the signal corroborated by multiple sources, providing stronger evidence that it is not merely a one-time anomaly. If the signal can be confirmed as coming from Andromeda and determined to be artificial, scientists will then face the formidable challenge of deciphering its meaning. Communication as we know it is an incredibly intricate process, and there is no assurance that an alien civilization would communicate in ways familiar to us. Human languages, for example, are constructed on shared experiences and references. We cannot assume that an extraterrestrial civilization would have the same biological, cultural, or technological frameworks as we do. They might not communicate through symbols, sounds, or mathematics in a way we can easily interpret, making the task of decoding the signal a monumental challenge. While the repeating nature of the signal provides scientists with a potential foothold for analysis, the complexity of understanding a message from another civilization cannot be overstated. Initial efforts will likely concentrate on breaking down the signal's structure, including its intervals, frequencies, and possible modulations. Researchers may search for patterns that suggest a logical sequence, such as prime numbers, geometric shapes, or mathematical constants, elements often considered universal signs of intelligence. However, even if patterns are detected, there is no guarantee that they correspond to a language or message we can decode. Some scientists speculate that the signal could resemble a cosmic hello, a simple indication of presence rather than a complex message. If this is the case, the signal's significance would lie not in its content, but in its very existence. The act of sending a signal could serve as a means for an alien civilization to announce its presence to the universe. Without necessarily seeking immediate communication, this leads to the intriguing possibility that other signals from distant galaxies may have already been transmitted, awaiting detection by advanced instruments like the James Webb Space Telescope. As the search for more signals intensifies, this event could herald a broader effort to understand the mechanisms of interstellar communication. If Andromeda or any other galaxy hosts an intelligent civilization, it is likely that they face similar challenges of vast cosmic distances and the limitations of the speed of light that we encounter. The detection of a signal from such a distant galaxy suggests that this civilization has found ways to overcome these obstacles in ways we have yet to fully comprehend. If they have mastered the ability to send signals across millions of light years, it implies a level of technological advancement far beyond our own. The implications of such a technological gap are profound. If this civilization has achieved intergalactic communication, what other capabilities might they possess? Could they have harnessed energy from their galaxy's stars, or even discovered ways to manipulate space-time itself? These questions push the boundaries of what we currently believe is scientifically possible, opening up new avenues for research, inquiry, and speculation. Feel free to express your opinion in the comments box. If you liked the video, press the like button and subscribe so you don't miss our next videos.